What is up? It is time for part 2 of the new flamethrower that I'm bringing to New York City Maker Faire 2018. This guy is gonna be completely mounted on my arm, no backpack, no extra anything, it's just all right on my arm. And let me tell you, it is coming along great. I've been printing parts out like crazy. Also picked out some hardware that's actually gonna be my nozzle. Nozzly. Because I did kind of blow through this guy when I was trying to sand it down, and I really want it to be nice and smooth and slide real cleanly inside of my little propane tank holder assembly, I'm gonna throw a little bit of body filler on it, and this is partially just because it's like really fun to do and I love putting Bondo on stuff, but also partially like I really want it to be smooth. I don't want there to be any chance that this thing could catch inside, because this is really what's controlling the gas flow. I want this to be super rock solid. So I'm gonna go ahead and take some of this stuff. I like the pre-mix stuff. I know it's probably a little more expensive to get the pre-mix, just like the spot putty, but honestly, it's like so much easier and definitely worth the money to just have a little bit that you like squirt out onto a tongue depressor and put on whatever you want instead of having to mix it up. And what if you mix too much and not worth it. Gonna hit it with heat for like 5 minutes or something. I just want all the kind of like darker beigey Bondo color to kind of just turn chalky and really light. Oh man, nothing is more satisfying than getting like a really nice smooth finish. And this, my friends, is an incredibly over smoothed adapter. There's no way this is gonna bind inside my assembly now. So the whole way this thing's getting assembled is with a bunch of 1/8 inch by 1/2 inch aluminum, and that goes into nice little slots in the 3D printed parts. Then I'm gonna drill a hole in the aluminum, tap the hole, and then use some like 440 hardware to hold it all in place. These are all getting mounted together at the elbow. So you can kind of see now how it becomes an arm apparatus. Well, that's actually super cool like this. Alright, so this flamethrower has an upper arm part and a lower arm part, so I need something that's gonna allow my elbow to move. So I've made this. These are two pieces that fit together. Inside there's like a standard skateboard bearing. It's like a 22 millimeter diameter, I forget. Standard skateboard bearing, and that just fits in this guy. That goes in there. I think there's a 1/4-20 bolt, and then this can just slide through like this, and I have a captive like hex head pattern. Oh, that is so satisfying. That will just like hold them in place. Throw a nut on the end. Bada bing, bada boom. There's a hinge. So this part on the end, actually there's still some support in there. I haven't gotten rid of it yet. But this guy, this is it's like 1/8 inch by 1/4 inch? Yeah, it's 1/8 inch by 1/2 inch aluminum stock that I'm pretty much using for all like the structural parts. So this is gonna slide into that, and then I'm gonna put some heat set inserts on this side, and then put some 440 screws straight through like that. That'll hold that in. That's the side that goes to the forearm. The upper arm part, I'm gonna put some in like this. I need to sand it, it's not quite fitting. But I'm gonna drill and tap some holes for 440s in here too, and then put them through that. I'm still waiting on the hardware to come in, but I can drill the holes in the meantime. And this is how my elbow is gonna articulate. Yeah. so here's my nozzle hardware. I have a little barbed end that goes onto my tubing. I have a little right angle, which is gonna shoot the fire up, and then I have a cap, which is gonna let me drill a hole about the size of the opening that I want the fire to come out of. I'm not quite sure what's gonna work. The smaller hole will make it come out faster. So if I drill a small hole, I should get some more distance, theoretically, but I'm gonna give it a try, drill a small hole, and then go up in size if that doesn't work out, because it's a lot easier to make a small hole bigger than to make a big hole smaller. Alright, so I've set up a little test rig here with my circuit that I prototyped out on a PCB to control the flamethrower. And then I also have my nozzle here with that really tiny hole that I just drilled. So now I'm going to give it a try and see how much gas comes out, what it looks like, and then I can decide if I want to change the size of the hole down the road. I'm going to turn on the solenoid valve. Good, so we got gas coming out. Let's light it up. It's actually pretty good for the lowest setting. Alright, I'm going to turn it up a little bit now. Interesting. Okay, so it put itself out. So my guess on what's happening is because the hole is so small, I have all this gas flow that needs to come through this really tiny hole, so it's going super fast. And because it's going so fast, it makes the fire go out. So what I think I might need to do is make the hole a little bigger, and then that way the gas won't be coming out quite as fast and it won't put itself out when I'm giving it max gas. Let's give that a try. I'm gonna drill a little bit bigger of a hole. Alright, so now I have a bigger hole in my nozzle, so I'm going to give this a try and see what this looks like. Okay, lowest gas setting, let's turn it on. That's weird. Oh my gosh. It's whistling. That is so wild. I made a whistle. A propane-powered whistle. Alright, so when I press my solenoid button, listen to this. That sound is the air whipping through the nozzle and whistling. How crazy is that? All right, whistling aside, let's test this sucker out. That's pretty good. That is sick. All right, I'm pretty happy with that. That feels pretty badass. Don't ever put your hand through fire like that. That was the dumbest thing I've ever done in my life. Don't ever do that. I can smell burnt hair now. Sweet! Awesome, that was great. All right, all of the mechanics are done. I've got a flamethrower gauntlet. I think this might be my favorite thing that I've ever built. Yeah, really stoked about the closing mechanisms. I tried 2 different ways to have the clasps close and like lock in. The first one was what I did last time that I built the flamethrower, which is like a little mechanism guy here that you can just like pull on this and it releases the little tab and then it will snap back in and hold itself in place with a little persuading, but it's not quite where I want it to be. Like it needs persuading, and also on the last one that I made when I used this mechanism, the whole frame was steel, but now the frame is like partially plastic, so it'll kind of bow a little bit, and it kind of does depend on the fact that it's not gonna bow when you close it in. I think what I'm gonna do is switch this one out for what I did on the other one, which is much simpler, and it's just a little aluminum tab here with a little plicky sticking out right there. And then I also have an adjoining slot on the other side. And the closing half wants to push out. So if I can just get it underneath and get it into the tab, it'll kind of hold itself in place. And this is like really, really simple, no moving parts. It's a good solution. And all you have to do to get it out is just a little bit of pressure to pop it back in. And it also just snaps closed, which is dope. So now what I need to do is work on the palm piece. So I tapped and drilled some holes in the bottom of my nozzle. So now what I need to do is design a PCB that has that hole pattern that I can screw it into, but also the PCB has to have traces for the sparks, for the spark gap, one of which needs to go to this, the other one needs to go to like an open slot where I can put a piece of like steel wire, copper wire or something to kind of be the second half of the circuit. And then I also need traces for the little selector switch, which I'm putting on the side, which is how I'm actually gonna control gas flow and all that.